And we're live. Hi, everyone. Welcome to this week's On.NET. My name is Cecil Phillip, and today we're going to be learning about machine learning with ML.NET. And, I think this is a perfect time for the show because just a couple of weeks ago, we were talking about how the folks from .NET Interactive were on. And there were just so many ML.NET questions. And so I'm really glad that Bree and Lewis are here to talk to us about it. So why don't we kick it off with some quick introductions? Bree, why don't we start with you? Why don't we let folks know who you are and what do you do?
All right. Hi, everyone. I'm Bree. I work on the .NET team, and I am the PM for ML.NET. You might have seen Louise and I talking about ML.NET in various other conferences or community stand-ups. But yeah, I'm very happy to be here to answer all your ML.NET questions.
Nice. And my friend, Luis?
Hey, how's it going, folks? I'm Luis. I am a content developer working across a variety of products, such as Azure Machine Learning, .NET for Apache Spark, and of course, ML.NET. As we mentioned, we do a lot of these, so you might have seen my face someplace else. But like Bree, I'm just happy to be here and talk to you folks how you can add ML.NET to your apps.
Awesome. And also, too, I want to give a shout out to our folks that are here watching us live. So we're streaming right now on Learn TV, YouTube, and also Twitch. And I can see in the chat, we have some folks here from Turkey. Someone's here from Austria. Hey, Gregor, what's going on? Definitely really appreciate y'all spending your time with us today. Before we dive into the topic, why don't we take a look at some links? I have some things I want to share with everyone before we kind of start talking about ML. So I'm going to share my screen. And the first link I want to share, I'm not sharing my screen. Come on, you could do it. There we go. All right. So first thing I want to share, this week on the community stand-up on the .NET YouTube channel, they had a discussion about minimal APIs, which I thought was really interesting. So, they had David Fowler, Steven, and Damien speaking about like some of the enhancements they're trying to make to the developer experience for APIs with ASP.NET Core. So again, this is already, was live and it was all recorded. So I definitely recommend you go ahead and check this out. And I have a feeling we might see a little bit of this later today. Maybe, maybe not. We'll see what happens, right? The next link I want to share with folks. So again, just in case you don't know, we are available on .NET Live TV. And if you go to .NET/live, what you'll be able to do is, you can scroll through here and you can see all the different shows and community stand-ups and things of that nature that we have streaming on .NET Live TV. As you can see right now, like this is us. So hopefully we're live and hopefully you're seeing us right now. But what you could also do, you see here on the right side, you can actually click on one of these links and check out some of the other shows and past recordings and stuff. So for instance, if you wanted to see the ML.NET community stand-up, you can actually click on this category here, for instance, click on machine learning. And then here you could look at, some of the past live streams and things of that nature that they've done. So if you've loved what you're going to see a little bit later today, definitely make sure you come over here and check out some of these past recordings for those live sessions that we have. And the last one that I want to share, so I'm in South Florida, so I'm a little biased to things that happen in the Southeast. No offense to anybody else. But we are having a Southern Data Science Conference. That's going to be happening on July 17th. I think it's going to be over the course of a few days. And you can register for it right now. So again, if you're in the Southeast or not, it's going to be completely online and definitely something worth checking out. What I'll do is I'll take the links for all these and I'll share them inside of the chat. So if you're interested in taking a look at, either that recording or, this data science conference, you'll have those links that you could go ahead and then click through. Now, with that being said, my screen's going to go away because, like I always like to say, this is not the Cecil show. Today is going to be like the Bree and Louise show. So why don't we start talking really quickly about like ML.NET? Like, give me the elevator pitch. Like, why is it? Why should I care about it? What is it for? I'm a .NET developer. I've been a .NET developer for a long time. I don't know anything about machine learning, right? Like, so tell me, how did this thing help me out?
Sure. Well, I guess our goal with ML.NET is to, as we say, democratize machine learning for .NET developers. So you are a perfect target customer. ML.NET is actually a machine learning framework. It's open source, cross-platform, and it's for .NET developers. So essentially, it allows .NET developers to stay in their ecosystem. You can use C#, F#, to train custom models, consume pre-trained models. So you can add custom machine learning models to your applications. And it makes it really easy because right now there's kind of this problem in the industry where say a data scientist or a developer that you train in Python, and then you have this model that's been trained in Python, and trying to integrate that back into a .NET application or get that model into production is not very easy. If you use .NET, then you know it's very easy to go to production with .NET, and ML.NET is .NET. So it makes bringing machine learning to production very easy.
Yeah, I think for me, it's always a case of, I mean, I understand what ML is from a bird's eye view, right? Like I understand like some of the interesting things that it's enabled, but where I struggle is always trying to figure out, well, how do I add it to my app, and then what kind of value can it add for me? So I think that's one of the things that I'm really looking forward to for us talking about is, again, for your typical line of business developer, or again, maybe you're building mobile apps, or any of these types of things. What are some of the really cool use cases that we could use with ML.NET?
Yeah, so I mean, there's a ton of different use cases for training classical machine learning models. There's classification, regression, anomaly detection, forecasting, and that may not mean anything to you if you've never done any machine learning stuff, but we try to simplify that in the tooling that we have. So for instance, when I say regression means trying to predict a value. And so we kind of frame it as value prediction. That could be predicting the price of a used car, predicting the price of a house based on how many rooms and bathrooms it has. As a practical example, there is a company called Evolution Software who's using ML.NET to predict they're using IoT sensors in these huge commercial dryers of 50,000 pounds of hazelnuts to try and predict the ideal moisture level of hazelnuts. So that's a value, and they're using ML.NET to predict that regression value. Internally, it's used at Microsoft for a ton of different things. If you've used Power BI, anomaly detector, or key influencers, powered by ML.NET, and it's machine learning. So Louise, I don't know if you have any other cool examples to add.
Yeah, not so much in examples, kind of taking it back just a little bit. You mentioned as somebody who's starting out, it may be hard to what bells or which buttons to push, right? And then certainly tooling does helps you a lot with that, specifically the automated machine learning, which ML.NET has, but so do many other frameworks. And even for practitioners, right? AutoML does a lot in terms of helping machine learning data scientists and machine learning developers, helping them find out what are the best things to choose based on their data, right? So it's not even for folks who are just starting out, though it certainly helps those folks. But also for folks who are already, experienced and seasoned practitioners, it helps them sort of speed up that experimentation process, which the process of building these machine learning models is very experimental.
Right, for sure. And so, Bree, I know you had some stuff you wanted to show us. Why don't I go ahead and put your desktop on camera, and then we can kind of go through some ML.NET stuff.
Totally. So I kind of already gave you an overview, a little bit of history. ML.NET started as a research project in Microsoft Research for text mining and search. It developed into this internal framework that's been used for over 10 years, and a ton of different popular machine learning features and products, and then became cross-platform and open source at Build of 2018. That was the first private preview of ML.NET, and since then we've just been growing and growing. Something to point out here is that ML.NET is extensible. So like I said, you can train custom machine learning models with ML.NET and then consume those models with ML.NET, or you can go out and you can train with TensorFlow or PyTorch, convert that to Onyx, and then consume Onyx and TensorFlow models in ML.NET. And a really popular use case here is you are a developer, you work with a data scientist who works in Python. So we don't want to pull people away from Python. We're not trying to pull Python lovers or data scientists away from Python. We just want to enable .NET, or we want to make .NET great for machine learning. So data scientists could train, let's say in PyTorch, they could convert that to an interchangeable format called Onyx, and then you could actually consume that Onyx model in ML.NET. Which makes it super easy. And I'll come down here just to show, we talked about some examples. So these are some of the more practical business examples. These all link to our samples repo. So it actually has the training code and how to consume it there. But you can see, anywhere from product recommendation to object detection to detecting sales spikes. You can see a ton of the different examples that you can use machine learning and ML.NET for. And I want to talk about the perf a little bit. A lot of this comes up a lot is, how does the performance of ML.NET compare to the other, Python frameworks? machine learning frameworks. And so here there was this experimental evaluation done between ML.NET, Scikit-learn, and H2O, which are other popular frameworks normally used for classical machine learning. And they did a bunch of experiments for different scenarios. So in this case, this was sentiment analysis, which is a classification scenario. And they used this huge Amazon review data set. For the full data set, which I can't remember exactly how large it was, but for the full data set, Scikit-learn and H2O couldn't even complete the training process. They ran into runtime errors. And ML.NET was able to run to completion. With a smaller subset of the data, it was about 900 megabytes of Amazon review data set, ML.NET outperformed both frameworks in terms of both accuracy and runtime. So that's the amount of time it took to train and test. So yeah, so you can read the whole paper. It's on the site here. I'm sure we can provide a link in the chat, but
Sure.
There's a whole paper that you can read to see the other evaluations that were done for the other different scenarios there.
Yeah, it's always interesting to me when folks ask the question, like, why do we have this thing in .NET? You know what I mean? It's kind of like when you look at what programming languages offer in general, right? Like no one asks, oh, well, why can I do web development in Python? Or why can I do this thing in Go or Rust, right? I think it's just, we have to look at it from the perspective of, we need, as a Microsoft particularly, we want our developers to be able to have these experiences regardless of whatever type of application they want to build, right? So if you want to build, again, web or mobile, you want to build a container thing, you want to build a cloud thing, you want to add machine learning or even just work on research projects and maybe build something a little bit more interactive with graphs and charts and things of that nature. Like we want to be able to do that and still leverage our skills as .NET developers. And so for me, even though I'm not like a data scientist and I don't work with this stuff a lot, for me, this sounds like the perfect place that I would start, because now I don't have to go learn another language. I could be like, I already know C#. I'm already familiar with .NET. I already have Visual Studio and my environment set up the way I want it to be set up. Now I just have to learn how this additional piece works so I can start adding it to the application that I already have.
Yeah, and that's one thing is if you don't know Python, obviously it's going to be a lot easier to learn machine learning in .NET. But the other thing is even if you did know Python and wanted to use Python, there's complexities and you can take some performance hits trying to integrate Python back into .NET. So that's why we make it easy in both cases. If you want to stay in .NET for everything you can with ML.NET, or if you wanted to train in Python and then bring that back into .NET through ML.NET, you can do that as well.
Yep, for sure.
And I think that's all I have here. I can talk about some of the use cases, but I can also get straight into the code and how to get started.
Yeah, let's do that.
Awesome.
Let's look at some code.
Sweet. So I'm going to open up Visual Studio. What I've done is, and I'll come back to this here, I've created a .NET 5 console application. And I am actually, in these few lines of codes, consuming an ML.NET model. I'm going to walk through what's happening here. So first, I'm prompting the user to write a review of a taxi driver. So in this case, I have a model that is going to tell me if the review left by the passenger is positive or negative sentiment. So prompting the user to write a review. And then what it's doing is it's creating this model input that has this comment property. So whatever is read in from the console is going to be set as the comment that is left as the review. Then what we're doing is we're calling this predict method on the sample data. So it has this comment here, and it's going to return this result. The result is going to contain the prediction of positive or negative. So here, if that prediction is positive, we're going to return a positive string. If it's negative, we're going to return something negative here. So I'm going to go ahead and run this, and then I'm going to get into how you actually train a model like this. And again, this is just a console application. So if I'm going to write a review of a taxi driver, let's say drove too fast. And so we would expect it to say negative. Let's see. Give it a second to. So what it's doing is it's actually using the model to predict based on this text that I sent it, is it positive or negative? So in this case, it says, we saw you had a bad experience. In that case, it detected, hey, this is a negative comment. Now let's try it, with a positive comment and see if we can get a positive result here, if our model is performing correctly. And this is just taking my free-form text and saying, hey, based on this text, it's positive or negative. Let's say car smelled good. And hopefully, we would hope that it would be a positive sentiment.
Yeah, I think that should be a positive sentiment. Let's go.
Yep. So in this case, it says, thanks for the great review. So it predicted, hey, this is positive. So yeah, that is consuming the model just in a .NET Core, .NET 5 console application. This is, and sentiment analysis is very much like a hello world machine learning type problem, which I've shown here. So now I want to show you how you can create one of these models on your own and do that really quickly without having machine learning knowledge, really.
That sounds perfect because I'm a big fan of being a lazy developer and having things just ready to go. So if there's components that I could kind of just plug in and start using, like that'll be fantastic.
Definitely. So I'm going to use what is ML.NET's tooling in Visual Studio called ML.NET Model Builder. The way you do that is you have your project. I'm going to right click on my project and I'm going to add machine learning. As easy as that.
Oh, that's cool. Okay.
Yeah. So we'll give it a second. It's going to open up the add new item dialog. If you've used Model Builder before, this will actually be a little bit different than the experience we had before. Before it would just open up the UI and go from there, and there was no saved state. But in this case, you'll see, and I'm going to name it, let's say, taxi fare model.
And then just for folks that may have not seen this before, so you right clicked and you did add machine learning. Is that something that's just built into Visual Studio, or do you have to like install a thing or create something to get that option?
While it's adding here, I'll actually show you. I think I have that link open. So it does ship with Visual Studio, but it is a preview feature. So you have to do a few extra steps in order to enable that. And I'll show you that here. This is the Getting Started tutorial on the website from .NET/ML. So in the Visual Studio installer and your .NET, any of the .NET workloads will have this. You want to make sure that ML.NET Model Builder is checked. So make sure you modify and make sure that it's checked. And then once it is and you're in Visual Studio, you want to go to your Tools, Options, Environment, and Preview features. And then there'll be this Enable Model Builder thing button here. You want to make sure that's checked. And as long as that is checked, you will be able to right-click on any .NET project and add machine learning.
Got it. Okay. Cool.
And that is what I've done. So I right-clicked, added machine learning. Oh, did not mean to do that. And it created this MB config file here. I'll dig into this MB config file at the end of training, but what it's doing is it's just a JSON file that's saving the state of each step. So I'll show you that once it's done training, but this is the UI that opened up as well that is associated with this MB config. If you've used WinForms before or WPF before, it's kind of like the designer, and then it'll have some code behind. So if you double click this, it will open up the designer UI. So my new model, I want to train a model that will predict the price of taxi fare based on, say, distance traveled, number of passengers, payment type, and a few other features. So in that case, it's this regression or value prediction. I want to predict a value. So I'm going to click the value prediction here. And for some of the scenarios, you do have the option to train locally with GPU or train in Azure ML. Those we have for our deep learning scenarios where you might have a lot more data that you need to train and might need more resources for that. In this case, I'm going to just train locally with my CPU. So my next step, I'm going to choose my, my training data, what I want to use to train the model or fit the model to. I have the option to choose from a file or SQL server. I just have it ready in a file. So I'm going to choose it from a file here.
Nice. I really like that scenario-based like UI. You know what I mean? So for me, that's definitely something that I could wrap my head around. It's like, you know, what's my business case for this thing? You know what I mean? I could pick from the available options and then kind of go forward from there.
Right, and that was very intentional, was to make it more scenario focused and not, you know, caught up on the data science machine learning terms there.
Sure. So some questions that folks are asking. Can we use this outside of Visual Studio? Is this UI available outside of Visual Studio? So meaning VS for Mac, and like what happens to VS Code folks as well?
Yeah, so right now the UI is only in Visual Studio, but we do have a cross-platform solution, which is the CLI. It's just a .NET global tool. It's called the ML.NET CLI. It does the same exact thing that this does. There's a few scenarios missing in the CLI. We're working to get scenario parity there, but that will work on, you know, Mac, Linux, Windows. And then we actually had a community member create a model builder extension for VS Code, which is very interesting. we're in the works on the team trying to see if we can actually open source this.
Yeah.
So that's something that we're actually working on. So that members of the community, if they wanted to extend it for whatever purpose they want, they can. Right now,
Sure.
unfortunately, it's not. So the UI, the short answer, UI is only in Visual Studio, but the functionality is available cross-platform with our other tooling.
I think that could be an interesting use case if folks decided to extend it, and then now they could add additional scenarios to that that first window that you showed us. It'd be interesting to see what kind of things people decide to create there.
Yeah, and we had a community member who there was some functionality missing, and we've since added it with choosing the column type or column purpose of the different columns in the data set. And he ended up creating his own version of Model Builder in a web app where that did the same exact thing, but with the added functionality that he needed, which is very interesting. Yeah, so that was pretty cool.
Very cool.
All right, so you can see that I have a little sample of my data set. There's about 50,000 rows in my data set, just showing the first 10. It has some sort of vendor ID, a rate code, number of passengers, the trip time of the taxi trip time, the trip distance, whether it's paid with card or cash, and then the actual fare amount at the end. So we're going to use this data set to train a model. So obviously right now we have a bunch of labeled data. We know what the fare amount is. We're going to use that to get this model that we can then use to predict on new data for fare amounts that we don't know yet. And again, this is called a regression task. And so I want to predict the fare amount. So that's what I'm going to do. I selected my data set. I selected fare amount as the column that I want to predict. There are some advanced data options here, which you can, like I said, choose if you want to ignore columns, if you don't want to use them for training, if you want to change the data type, and like changing whether it has a header or not. But we do a pretty good job of predicting what your data set looks like. But you can override that if you need to. So then I'm going to come here and I'm going to train. So you can choose a time to train. It does suggest it based on the data set size. Sometimes you may need to train longer. I'm going to train for 60 seconds because I'm streaming live and sharing my screen and everything. And this is all using my CPU. Yeah. But I'm also going to talk about what is happening when I hit train. So Luis alluded to this earlier, but automated machine learning or AutoML is this feature that ML.NET offers and other machine learning frameworks do as well. And what it does is it automates that model experimentation process. So in the given amount of time that I give it for training, it will iterate through different algorithms, algorithm options based on the scenario and the data set that I give it. And then at the end of that time, it will choose the best model based on some performance evaluation metric. In the case of regression, it looks at a metric called R squared. So we'll let that keep going, and I think it does show up.
So one question too, I want to pop in with and ask really quickly. So you mentioned just now that you're doing the training locally. Is there an option for remote training? Like maybe I could shell it out to the cloud or to a VM or something and have those results aggregated and pulled back from it?
Yeah, so before I answer that question, it looks like I didn't give it enough time to find a model. And again, that's probably because I'm streaming and everything. So let's give it a little more time to train. Let's just double the time and see if that helps. So, and to answer your question about training remotely, and in this case, it might have helped. Right now, the two scenarios we support for training remotely are image classification and object detection, which are it's part of the subset of machine learning called deep learning. And it will take a lot more resources because, it's image data. So you can, and that's actually right from the UI will connect you to Azure ML, and it will train using Azure ML and then bring back down your model as an ML.NET model.
Got it. And then speaking of deep learning, so Jose in the chat, Jose is coming into us from YouTube. And Jose is asking, how to call ML.NET and how to call TensorFlow or PyTorch? I'm guessing he's asking, how do I do deep learning / PyTorch / TensorFlow integration with ML.NET?
Sure. Louise, you want to answer that one?
Sure, yeah. So you can extend ML.NET if you have a TensorFlow model. There is a transform in ML.NET, which you can, I believe it's called Score TensorFlow. And basically you can take your protobuf file or your PB file, in TensorFlow, and you can bring it in and you can score and make predictions with that model. With PyTorch, you can do that if you can score PyTorch models if you convert them to Onyx first. So the transform there is called apply Onyx, and that will essentially allow you to make predictions using your PyTorch models. So that's how you would do that inside of ML.NET. And hopefully that answers your question, Jose.
Sure. And then we have one more question coming in that I'm going to try and get up really quickly. This person's asking, should we know Python as well? So I'm guessing it's around not just specifically for deep learning, but just in general. How much do I need to know Python to get into machine learning and stuff? Or, can I just kind of get away with being like blissfully ignorant and just focusing on .NET?
I'll let Luis take that again.
Yeah. I think that, well, to get started with Model Builder, I mean, honestly, you don't even need to know C# because the model is trained for you, or .NET in general, right? Because everything is sort of done for you. You just click through this wizard-like experience. Of course, later on when you want to deploy it and do other things, maybe you want to tweak a few things. Of course, you need to know .NET. But in terms of Python, you don't need to know much at all to work with ML.NET. Actually, you need to know none at all to work with ML.NET. But it doesn't hurt, for example, if there are, for example, scenarios that maybe ML.NET currently does not natively support, right? Such as the example that we discussed with Jose here with PyTorch, right? Perhaps you have PyTorch and you working in Python there. In those scenarios, of course, it helps because you're going to need to perform some conversions before getting that model into ML.NET. So short story, very little. But, obviously it doesn't hurt to know Python.
Sure. And then our friend Seth Warres is in the chat right now. And Seth's saying, one good workflow is to train in PyTorch or TensorFlow and use the models for inference in ML.NET.
Yep. Spot on.
Exactly. Yep.
Nice.
Okay.
Cool. All right. I'll let you guys get back to it.
Bring it back to our demo. So in the time that I gave it, it was able to explore one model, and that one model used the fast forest regression algorithm and gave me an R-squared of 0.81, which is not so bad. It's pretty good, actually. If I go to the evaluate screen, I can test out my model right in the UI. So this just pre-filled up by the second row of data. So when I hit predict, it's using the model just to try it out on the UI before getting into the code. So it's saying the fair amount is predicted to be about $8.30. If I go back to my data set, the second row of data, so it'll have all the same data, give $8. So the actual amount was $8 and our model predicted $8.30. I would say that's close enough there. And so here, once I trained the model, these 3 files were added to my MB config. This zip file is the actual model itself. So ML.NET models are serialized zip files. This training.cs file is the training pipeline that AutoML chose for my model. So if we come down here, this is going to look like a lot. It was all auto-generated by the tooling. This is the data transformations that were chosen based on my data set and my scenario. So you can see, it appended quite a few data transformations, and then it chose the fast forest regression algorithm. So it added that, what we call a trainer algorithm, to the pipeline. And then it actually went and tuned some of the hyperparameters. So you can imagine if you're trying to do this yourself, you have to, one, know the data transforms needed for all your data in order to get it into the right format for the algorithm for training. You have to then choose an algorithm, and then you have to try to tune the algorithm options or hyperparameters in order to get your best model. And in this case, AutoML and Model Builder took care of all that for me and then generated the code. And what's nice about this is if I wanted to retrain my model, I could just take this file and retrain on the same pipeline, which is a really common scenario. If you're constantly getting new data or data is changing, you can even integrate this with your current CI/CD pipeline and say every time you get a new data, you can retrain with this pipeline.
Got it.
Yeah.
And now, since you mentioned CI/CD, we did have a question in YouTube right now, and this one's coming from Andre. Andre's asking, how can we deploy ML.NET and its trained models? So is there a particular artifact that we have, or is it just C# code and we're just funneling it back and forth, or is there like a thing that has like the trained model?
So that's actually part of the demo. So if you wanted to hold off for a second, and once we hand it over to Louise, we'll actually show you.
Let's do that. Let's do that.
That's okay. I'll just do a quick look into this consumption file. This is what you need to consume the model. You have this model input class, which will be the data schema. We've seen this as the columns that we have in the data set. And then this is going to be what's returned from the model. we will return a score, which is our prediction or the predicted taxi fare. And then down here, this is that predict function that you might remember from the sentiment analysis example, where you're putting in your model input that you've set. You're creating this new ML, or I guess the method is creating this new ML context, which is the starting point of all ML.NET operations. And then you are loading in the model that was trained. You're creating this prediction engine. A prediction engine is a convenience API for making single predictions. And then you're creating this prediction engine based on the data schema for model input and output, and based on your trained model. And then you can use that prediction engine's predict function on the input that you set. So okay. I have this model. I want to use it. I want to deploy it. I'm not the deployment expert. I have someone else on my team that does that, who happens to be Louise. So I've added the regression model. I have Git here. So I have this branch called add regression model, and then I'm going to commit this, and we'll save everything there. And once that is done, I will be able to push it, and then we'll switch over to Louise. And while I'm doing this, if there's another question we can answer.
Yeah, we do have a few questions for sure. So the first one that I want to jump in with, again, this is one is also coming in from YouTube. And this person's asking, does the designer only work in certain project types? So for instance, WPF, or is it just available everywhere?
Any .NET application that you did. So this was a console app. I've done it for WPF, WinForms, any sort of web app. You'll actually see a web example as soon as we go over to Louise. So just any .NET application will work. The only, I guess, caveat is it only generates C# code right now. But definitely producing F# code is something that has been on our minds for a while as well.
Got it. And then another question also from YouTube. Is there a minimum version of Visual Studio that you need to use the model builder?
Yeah, for the newer versions, 2019 for sure. I believe some of our older versions work on 2017 because we developed it, I think, a year ago, a year or two ago. So I would definitely recommend using 2019 for it. Because any new changes that we make will be for 2019, and then the newer version that's coming out later this year.
Got it. And then one more question before we let you get back to the demo. So this is also coming in from YouTube, and the person's asking how to retrain a model with data streaming.
Louise?
Yeah, so this is a scenario that is currently supported. So I presume, Niranjan, that what you're referring to there is you want to immediately, as soon as you get data, or perhaps you batch it up, and maybe after an hour or so, when you've collected enough data, you want to go ahead and retrain your model. So there's two ways to do that. One would be to obviously just kick off this process again, right? So run the code that Bree kind of showed off here for your training pipeline, run that again with the new data set that you're running. The only thing to keep in mind there, though, is that it's not incremental retraining, meaning that you lose the knowledge that your model had beforehand, and you're just completely basically building a brand new model. And that is, like I said, it's just simple as rerunning this script here, right? There is also the incremental training scenario where as soon as you get new data, you remember, or it recalls the past data and just continues to add on based on the new data that it gets, right? So both scenarios are certainly possible. Through Model Builder, the first scenario is the one that's available, right, where you're training with new data. And then if you're using the API, there are ways that you can, perform that sort of incremental retraining. But the other thing to keep in mind is that it's only on a subset of algorithms that's supported. So things to consider there.
Yeah, and that kind of makes me think about like versioning, right? Like, so as you're doing like these incremental trainings, and I'm guessing every training output is like a different version of your model, right? So outside of how we as developers generally think about like, version control for our code, is there any specific or particular techniques or patterns that, that are used in the model training world for versioning our models, or is it just kind of all the same thing?
Yeah, so there's something called ML Ops, which is kind of this broad term. It's almost like DevOps for machine learning, but it kind of covers the CI/CD portion and the automatic retraining, as well as experiment tracking, model and data versioning. So right now it's kind of being defined in general, like by the industry. It's the best practices, I think, are still being evolved. And it's a space that we're currently working in as well for ML.NET and trying to figure out, I think, Azure ML does a pretty good job, and I think Luis can speak more to that because he works on Azure ML. They have their own ML ops stuff and data and model versioning.
Got it. And then let's do one more question, and then we'll get back to the demo. And Andre from YouTube is asking, which model format files can be used with ML.NET?
So the output of an ML.NET model when you train is a zip file. But as for outside frameworks, you can directly use TensorFlow models in ML.NET, and you can use Onyx models as well. So if you trained in PyTorch, you could convert that to Onyx and then consume that with ML.NET.
Cool. All right. All right. So I think your code's checked in now. So what do we do now?
So let's switch over to Luis so he can pull those changes and get to deploying the model.
All right, Luis, you have front stage.
All right. Awesome. All right. Let me try the UI here. I'm not quite as proficient with the UI getting stuff. So let's go ahead and pull. And you'll see that I'm using this branch that Bree has created. So I should be getting latest changes. And there we go. So before we didn't have this taxi fare model. I'll zoom in a little bit for folks here. There's that taxi fare model MB config. And again, you'll notice that in it is also that consumption file, the training file, as well as the model.zip, which is the actual model asset that we're going to be deploying. Now, at this point, what we want to do is we want to pick up where Bree left off. So to do that, we go ahead and click on the MB config file for our taxi fare model. You're going to see that it's going to bring us right back into that UI. So what I want to do now is I want to click on this evaluate tab here. Sorry, the consume tab here. And you're going to see that there's a code snippet if I want to go ahead and consume my application in some sort of console app and consume my model there. I also have a option here to export a full console app similar to the one that Bree showed off where she was doing some sentiment analysis. And you can consume and deploy your model to a console app, but the use case there may vary. Something that is a little bit more common is to take these models and deploy them as web APIs. So you expose some sort of endpoint that you take in requests, and the request would contain the input that your model is expecting. It will use the model to then make a prediction and then return the prediction back to you, right? So that's a fairly common scenario. And you're going to see here in the sample projects, the web API is actually an ASP.NET Core web API that you can go ahead and create. So if I go ahead and click on add to solution here, you're going to see that it's going to ask me, hey, what's the model of your API that you want to, or what's the name of your web API? I'm just going to call it text for model web API. And then I'm going to go ahead and add it to my solution. Now, what that's going to do is it's going to scaffold a brand new web API project for me. And the web API project is going to contain two files really. It's this program.cs and this MB config file, which is going to be that model again, right? So there's that. So it automatically embeds the model that I trained elsewhere. So you're going to see that this is an ASP.NET Core Web API. So you may be asking yourself, well, where's my startup file? Where is my controllers or my www root directory, right? And none of that is there, but it's still a full-on ASP.NET Core Web API. And let me just get out of this for a second here. The difference is we tried to simplify it just a little bit because all you need is to have a single endpoint. And to have a single endpoint, you don't really need to have sort of all the bells and whistles that sort of ASP.NET Core gives you out of the box, right? So for somebody that just wants to deploy this single asset and handle requests through a single endpoint, this is a way that you could simplify it. Now, the technique that is being used here is known as route to code, and that technique sort of leverages endpoint routing. And when you use that technique, you're able to sort of shrink down the size of your web API into a single file, right? So you're going to see here, this is going to look very familiar if you're a ASP.NET developer, right? We start off with a web host and we create our builder. These sections here, the configure services and the configure, are things that you would traditionally find inside of your startup.cs file. But in this case, again, because we don't need a lot, we just brought them all into here. And we start off by configuring our services. The only one service that we're going to need here is this add prediction engine pool. Now, one of the things that you have to note is that the prediction engine and that convenience API, it is not thread safe. So when you're deploying it to these sort of multi-threaded and these applications that are going to be handling a lot of concurrent requests like a lot of ASP.NET applications do, you're going to need something that's a little bit more robust. And that's where the prediction engine pool comes in. It basically creates an object pool of prediction engine objects that you can then just pick from as requests come in, make use of them, make a prediction, and then sort of return them back into the pool to be reused at a later time. Right. So that's what this service is doing for you. You're going to see that I'm telling it, hey, I want this model input to be the input that I'm going to expect in my prediction engine, and this is going to be the output. And there's two ways actually to use this prediction engine pool service. One is you're able to bring in a model that's in a file. Now, in this case, we're using that taxifairmodel.zip file. But the thing is that you may not always have your model embedded as part of your application. Perhaps it's in some other blob storage or some other public endpoint, right? In that case, what you can do is you can use the from URI, and that's going to pull your model, even though it may not be embedded as part of your application, it's going to go ahead and pull it down from that location where that model is, right? Another really neat feature of this service here is that it does automatic reloading. So going back to that sort of retraining scenario where perhaps you got new data, you had to retrain it, and then you need to sort of redeploy your model or embed a new model inside of your application. What you're able to do here is this service has this sort of auto reload service that's checking in the background. I believe by default, it checks every 5 minutes to see, hey, has the file or has the asset that I'm getting my file from remotely, has the state of that changed? And if so, pull in the latest version. And you don't have to essentially take down or restart your application to do that. It does that automatically for you. So now that you have your prediction engine pool service and you've sort of configured it to be later used using dependency injection, you then go to your configure method where you, again, tell it, hey, use routing because we're going to be using endpoint routing. And we define a single endpoint, which is this predict endpoint that's going to be expecting a post request. Now, this predict endpoint will handle your request and do stuff with it. And to do that, it uses this predict handler. In the predict handler, it looks very similar to the handlers that your ASP.NET applications contain, right? It takes your HTTP context. Then inside of this predict handler, we go ahead and we request that prediction engine pool service. We then just do some parsing of the body. We serialize the body. We use that prediction engine pool to make a prediction. And then we write the output back out as JSON so that it returns the response to, to what our client or whoever is making a request here to our application. So let's go ahead and test that out locally to see kind of what this looks like. So we go here, and then we start up our Taxifair Model Web API. This is going to start up our server, and then we can make requests against this. So I'm going to be using Insomnia here to make requests. And again, I'm going to be making a request to this localhost 5000/predict endpoint.
And while you're waiting for your thing to
Yes.
spin up really quickly, we did have some questions pop in.
Mm-hmm.
This one's coming in from Twitch, and this person's asking, can we also add it to an MVC project solution? And I'm guessing when he says MVC, they mean ASP.NET Framework MVC versus ASP.NET Core MVC.
Yep, absolutely. You can. Again, as long as you're embedding this, the zip asset, right? The ML.NET model asset, you can leverage this add prediction engine pool, register it using dependency injection, right? For use with dependency injection, and just tell it, hey, this is the model that I'm going to be using. And now you can use it throughout your application. You can use it in your action methods, right, of your MVC and so on and so forth. And you can use it in Blazor as well. So yes.
Sure. And then Andre also from YouTube is asking, can we train our model offline just using ML.NET?
Yeah, that's what we did here.
I'm guessing that's yes.
Yep. Yeah. ML.NET is offline first. And you also have the option again for those scenarios, deep learning scenarios, to go to Azure.
Yeah. And then Gregor is in here asking a question. Any plans of adding the same functionality for the time series prediction engine? I'm guessing y'all know what that. I have no idea what that is.
Yeah, that's a really good question. Yeah, go ahead, Bree.
No, so Louise and I were actually looking at this recently because we were doing a demo with forecasting, and I believe that you don't need to have this There was a whole issue on it on GitHub about it. They were commenting. I think you don't need to have it be thread safe. Do you remember what the reasoning was, Luis? Do you
No,
remember this at all?
yeah, no. So to be clear, for time prediction, so for time series predictions, it is not built in. So you are right, Gregor, that is not built in. But we're exploring as to whether you might need it, because time series prediction is a little bit different in the sense that there is no model per se, right? You just give it some information and it tries to understand the patterns. At least in ML.NET, that's certainly the way it works. It tries to understand the patterns, its seasonality, things like that. But it doesn't actually build a model per se. So it's a little bit different. But it is something that we're looking at. And yeah, if that's something you'd like to see, we'd love to get some of that feedback in the repo. Yeah.
Nice. And then just one more question, and then I'll let you keep going. So this one's also coming in from YouTube. And the question is, with API integration, it seems that each model will only have one endpoint. Is there any way that we can have multiple endpoints in the same API deployment, but have many models?
Yep, absolutely. So you can register as many prediction engine pools here as you want. And there's even, I don't know, I have the application running, so I don't know if I'll be able to show that. But there's a way here that you can add another parameter called, I believe it's model name, and you're able to reference it by name. So when you're pulling it in here, you tell it get required service, and you tell it to get this prediction engine pool. You can say, I want this particular model to come in to this part of my application. So yes, you can register as many as you want. All right, so let's see. I think it started off already. Making a request to HTTPS. When it's HTTP. So when we go ahead and make a request, this is, again, the input right. That's that vendor ID, your rate code, your passenger count, so on and so forth. And you see here that it just returns to me the score or the predicted fare for that, right? So we know that we tested it locally. We know it's working. Great. So what do we do next? Well, this is a .NET application, right? So the natural step to deploy then after that, or at least one of the simpler methods to deploy, is to go ahead and right-click and publish, right? So folks who may be used to deploying applications within Visual Studio, you can certainly take advantage of that right-click publish functionality, right? So if we go here to Azure, right, we go through the steps. In this case, we're going to be deploying it to Azure App Service. And I'm going to go ahead and create a few things here. So we're going to want to select our app service instance here.
Wait 1 second.
Yep.
It looks like we just got rated with 261 people from Lanalux. So thank you everyone that are joining us right now. That's 261 people. That's a lot of people. So what we're doing right now for all of you that are joining us now, this is on .NET Live, and we are talking about adding machine learning to your existing .NET application. So if you're, C# or ASP.NET, or you build any types of apps using Visual Studio using .NET, this is a really cool way for you to start adding machine learning functionality, but not knowing too much about machine learning. So I definitely really appreciate all of these people that are joining us now. Hopefully you guys will stick around and consume some of this great content that Bree and Louise are showing us today.
Yeah, it's pretty awesome. And it actually was very timely because that usually takes a while to spin up there. So thanks, folks. And again, thanks for joining us and getting to see some of this content here. All right, so then we could just go ahead and tell it that we want to publish it. Again, this is for folks who are used to doing this. It shouldn't feel it shouldn't feel like something different, right? It should feel very familiar. And that's the whole point, right? That at the end of the day, these ML.NET models, and even if you are bringing in Onyx or TensorFlow models, the way that you deploy them and the way that you get them into production should feel very, very familiar to you. So now I'm going to go ahead and publish it. And again, what I want to kind of show here is that eventually it's going to go ahead and work here once I deploy it to my public endpoint. Now, this might take a while. So while that's happening, I just want to talk about something else, and you kind of alluded to
Sure.
Cecil. So you'll notice here that we're using this technique again, route to code. One of the challenges here is, or the trade-offs is, it does make it simpler, but you lose some of the features like model binding that you typically get inside of the ASP.NET framework. Some of the things that you're used to using right? So there's certainly trade-offs there. But what if I told you that you didn't have to make a trade-off and that it could be even simpler than this, but at the same time, you get to basically use all the functionality and really the full weight of the ASP.NET framework. And you actually can do that with minimal APIs. So let me just switch over here to VS Code real quick to kind of show you what the code looks like. This is using, I believe, Preview 5 of .NET 6. So it's using the latest bits. And I believe this is C# 10 that it's using. And you're going to see here, it's going to look very similar in the sort of create builder functionality, except instead of using web host, we're using this web application method here or class. Then we go ahead and say, hey, builder, I want to register my prediction engine pool. In this case, we're using one of those, remote models that we have, stored on GitHub. And then we just build our application. Then we go ahead and we say, hey, map this predict endpoint. And what we're injecting here, instead of, so very similar to what we did before, where we had that sort of predict handler, except in here, we're actually just using a Lambda. So, or sort of an anonymous function, right? And as you can see here, right, we're using from services, just like you would with your traditional sort of MVC applications, to bring in our prediction engine pool. And the model input, we're sort of bringing that in and parsing it from our body, right? And then all we do is we just say prediction engine pool predict, and then to run our application, we tell it app.run, and that's it. Like that's the extent of what you need to do to deploy an ML.NET model as a web API using this minimal API sort of new app model convention that should be coming. And that was actually, there's more in-depth sort of materials if you go and check out the ASP.NET stand-up that happened yesterday that Cecil mentioned at the beginning of the stream. So if you'd like to learn more about minimal APIs, check that out. And then this is just sort of an example of, well, this is what it looks like when you actually want to leverage that app model to go ahead and simplify and deploy ML.NET models as web APIs.
Yeah, I think between the new minimal API features that are being built in for ASP.NET Core and then the new C# language features, I kind of feel like my .NET applications keep shrinking, right? They get smaller and smaller. I don't need namespaces if I don't have to. I don't need that enclosing program or, public static void main if I don't need it. And I can kind of just write code, which I think is amazing. And so now you have pretty much a fully functioning application, like a non-trivial functioning application in less than 20 lines of code, which is great.
Yep, totally. And again, in these scenarios, because they're so simple, right? Like for the most part, you need one endpoint. That's really all you need. So I think this deployed now. I think it said it was successful. So now if we make a request to that endpoint with, again, our same sort of body here, you're going to see that we get the same response. So it was that easy to go from, hey, we not only got the code to build the model and got that sort of scaffolded and auto-generated for us, but we also had the actual application that we're going to deploy to the cloud in Azure, scaffolded for us as well. And again, with a right-click publish sort of workflow, we can easily get that into Azure and out to our customers. So I'll pause there because I know we're actually running a bit low on time here. So maybe we want to take some questions from folks.
Yeah, that's fine. I mean, we can go over too if we needed to. So that's totally fine. Yeah, I mean, there's some folks in the chat that are commenting about you running code directly from the main branch and having C# 10 and stuff like that on your machine. Some folks are asking about this conference. I think you guys are doing a conference this week or tomorrow. Actually, I think maybe it's today. I think it says it's going to start in a couple hours, the virtual ML.NET conference.
I hope it doesn't start in a couple hours. It starts tomorrow in about 9 hours, actually. It's the virtual ML.NET community conference, completely run by the community. All sessions are by community members. Louise and I help co-host a bit, but it's pretty much, and I have it on my screen here. There's the countdown for it. There's an awesome schedule of talks, and I'll go to the schedule here. We'll post the link in the chat as well. This was started last year by two community members, John Wood and Alexander Slate. They just got together on Twitter and were like, hey, we wish there was an all ML.NET conference. And then they made it happen. So this is the second. The first one was last March or May, I believe. Then there was a kind of a spin-off hackathon in November. And then now this is the second annual ML.NET or virtual ML.NET community conference. So I believe there's 13-ish sessions, everything from, the kind of the intro to ML.NET to using ML.NET in Xbox. Let's perform anomaly detection using ML.NET on a drone flying data from Azure IoT. So you can see there's quite a few awesome ones here. Let's play rock, paper, scissors with ML.NET. You might have seen, I think Scott Hanselman has had a talk with the rock, paper, scissors, and now it'll be integrated with ML.NET. So a lot of really, really cool sessions, both tomorrow and the next day. So we'll post a link in the chat for that.
Yeah, I'm wondering if there's a bug in the timer. The reason I'm saying this is because there's a few folks in the chat that are saying that they were seeing the timer says it starts in 5 hours. I'm looking on my screen, like I like when I refresh my page, it says it starts in 6 hours. I'm looking at your page and it says 9 hours. So I feel like everyone that's on the site is seeing
9 hours is tonight. I should have done the math in my head. I'm like, wait, 9 hours? That does not make it 7 a.m. tomorrow. Yeah, there's probably don't look at that. Hopefully, so the schedule page should be adjusted to your time zone. Like I'm in Pacific time, and this starts, in the they've been timing it on Eastern time zone. So I'll be up very early for this. I'm sure lots of you will be either up very early or late to watch as well. But yeah, I would if you actually go to the schedule page, and I can put that link in the chat here. You should be able to see it based on your time zone.
Got it. And then for folks that, may be sleeping when some of these sessions are going on, I'm guessing it'll be recorded and probably available on YouTube or some streaming platform that folks could watch.
Exactly. Yeah. VirtualML.net has its own YouTube channel, and it has all the sessions from last year as well. So we will record all those and put it on YouTube again.
Awesome. Cool. And then would you both are going to be speaking there, right? I'm guessing you guys are both doing something.
This year we're not. It's all community led this year. Yeah.
No.
We'll be helping co-host. We'll be helping moderate co-host, but yeah, it's all community led, which we're very excited about.
Got it. Okay. All right. So then I went ahead and pasted that link in the chat. So if folks are interested in checking out the conference, I'm sure you could still go ahead and register for it right now if you wanted to. And then hopefully you'll learn some more about ML.NET and see what some of the other community members have been working on.
Awesome. Any other questions for us, Cecil?
None that I want to put on screen.
Okay.
Here's one from Jose. Jose is asking, can I train my model without Visual Studio and just using my software made in ML.NET? So I'm guessing he's asking about like command line execution, which we did mention a little bit earlier, but he may or may not have been here for it. So you wanna talk about that again really quickly about how you can train outside of that Visual Studio UI?
Yeah, so the ML.NET APIs, like you can build the pipelines yourself. So the auto-generated pipeline that was from tooling, you can totally build that up yourself and go for a code-first approach. We also have a layer on top of the ML.NET API, that's the AutoML.NET API, which is abstracting away that portion of it. So it's essentially everything that the tooling does, but in code. So you would say, create regression experiment, put in your data set and the amount of time to train, and then it would give you back that model. And then on top of that is what we have our tooling on. And I think Louise had an example of the CLI. If we switch over to his screen, you may be able to see you can see what the CLI looks like.
Yeah, you can, and we won't go through the training example because again, I know that we're running a bit low on time, but let me switch over here.
Sure.
Yep. Okay. Yep. So you can see here, I have installed the CLI, and you can say mlnet-h, and this is a global .NET tool, right? So you install with the .NET tool install mlnet, and as you can see here, it's basically what Bree was mentioning, where you have classification, regression, recommendation, and image classification. And then you see this other train command here, and that train command, what it allows you to do is, we already have this mb config file here. So what we can do is we can tell mlnet net train, and I'm just going to do the H so you can see the different options that you get. But essentially, it should just pull up where is the path to that training config file, and then it's going to retrain based on basically whatever has been defined inside of your MB config. So you could imagine even using the CLI inside of your CI/CD or some sort of automated process to retrain these models.
We have one more question that just popped in. So this was from Jeremy St. Clair. in YouTube. And Jeremy's pretty much asking, how many pictures would I need in order to have a high level of accuracy if I want to detect beans in an image? So I'm guessing Jeremy's a bean counter. So and he wants to make sure that he has good beans. So
it's going to be the answer that everybody loves. It depends.
Exactly.
Yeah, it really does. It really depends. There's two camps of like more data always helps. But again, like let's say that you have more data, but it's only like one type of bean, right? Like that's not very helpful. So you also need to balance it between lots of data, but that data also needs to be diverse. And
right,
how much data, it's going to depend.
Not only different types of beans, but different angles of the same bean. There's a lot of different ways that you can do it. We actually, Luis and I did an American Sign Language image classification model a while back, which it doesn't really work well for that scenario because there's a lot of movement and expression in the face, but it did actually pick up some of the symbols or some of the, the hand motions there, which was really, really cool. But we needed, so for each letter, we had to have, I don't remember how many images we had, but it was like all around, all different placement on the screen, different angles, different lighting. So the more variation you have in your images, the better.
Got it. We have some more questions that are coming in from Twitch. This person's saying, I'm a student learning C# and I have to make an authentication on ASP.NET Core and MVC. Do you guys have some tutorials? Louis, you're a content developer. Do you know?
Check the docs. Yeah, no. So, on the fly, I can't really pull them out. But if you go to docs.microsoft.com, there's tons of content there. And I think there's also even one of these live shows, right? I think it's called the 425 show that may be dedicated to authentication.
That's right.
Yeah, exactly. So make sure to check if you're more of a visual learner, check out the show. But there's also written content in docs.microsoft.com.
Yeah, for sure. Definitely want to shout out Christos. So again, you can see the 425 show on YouTube. They have their own YouTube channel and they also have their own Twitch channel as well. So you can search for 425. Is it 425 or 429? I don't remember which one it is.
I forget. Yeah, it's 420 something. So
search for the 420 something show for security, and you can find
the
it
420 something show.
It'd be great. Some questions coming in from YouTube. So, is there a timeline for the current preview release?
Yeah, so ML.NET is currently GA, so that's not in preview anymore. We have our own, we don't follow the .NET or Visual Studio release cadences, just to have a little more flexibility right now. We try to release every month. I think we've been a little slow on that recently, but the newest Model Builder release you can currently use. It's on a private NuGet feed, so we actually have a link, and maybe if Louise can find it and post it in the chat, you can sign up for this one. Or if you want to wait for build, we'll have this release out. So all the features that I showed, if you go through those steps of enabling Model Builder, that will be the version that you get.
Awesome.
So, yeah.
Great. Cool. So yeah, so kind of like what Louis was saying a little bit earlier, we are running low on time. So for you two, is there anything else that we want to show folks or talk to them about or share before we wrap it up?
Nothing on my end. I mean, we're always here for any questions. If you need help getting started, if it is open source. So if you want to contribute or have issues, you can, do that on the .NET/machine learning GitHub repo. And we really hope that you come see the virtual ML.NET community conference. It's going to be really awesome. It's going to be streaming on Twitch and YouTube, and it's completely free. You can just watch and ask questions. It's going to be the same, format here. So nothing else to add, Luis?
No, thanks for having us. We really enjoy talking to folks and helping .NET developers, make their apps more intelligent with ML.NET. And again, like Bree said, we're happy to talk if you have questions. And and thanks for having us, folks.
Yeah, for sure. Again, so thank you too for joining us, and then thank everyone that joined us here in the live chat. I know earlier we shouted out a few countries, and I know a bunch more folks joined us. I saw some folks join from Canada. We had some more folks join from Turkey and Israel, and like tons of amazing places. So as always, I really appreciate y'all spending this time with us, and hopefully you come back again next week as we'll do another on .NET Live. So see you all. Have a good day, and we'll talk to you soon.
Thanks.
Now I have to find the music. Where's the music?
I could sing it for you.
Is this the music? Are you going to sing, Brie? Go for it.
No, just kidding. I take cut off.
That's the encore part of the show.
Nobody would come back to your show if they heard me sing.
That's funny. Okay, I found the music now. We're gonna go. Bye, everybody.